Hi, so this is the topic of structural analysis that we have to determine the force in each member of the truss, or like having the clue of the is it the force tension or compressive. But in this problem we are required to find everything of it. And we have seen that this is the pin and this is the roller. So the pin will have two force and the roller only have one force like this. And the problem stated that the angle of it is 30 degree. Here is 30 degree. So the geometry of it is like this. It is somehow the reflection of the angle in geometry. So yeah. And in this we have 4 points, 4 joints as well. So I would like to choose the methods of joints to solve this problem. It's quite easier than the section method of section. So we have to draw the free body diagram and all the necessary parts that we have just to add it into the free body diagram, such as the given force and the hidden force that we don't. You can actually find this file in the description box below. I will upload the picture or the file of this problem and solution. But so here we have for the support reaction on the truss. It's like the overall stuff here that we have, how to make it equilibrium. So we have to determine the moment because there are three missing parts, right? The NC here and the AY and AX here, as you can remember. So we have to find the NC, the AX, and the AY. Yes, so the equilibrium is like how to make it balance, because the subject is about statics, it's not dynamic, so there won't be any movement. It's like just to make it stable. And the moment of equilibrium is, we just find it as normal, and we have found these three values that we needed later for the sections and the joints method. So here we start from joint C, because joint C is easier than other joints as we have known the number for most of it already. So we have found the force CD and the force CB. First, we might not know if it's compressive or tension, because in the free body diagram there's only things like this. But if you're not pretty sure about whether it's going here or it's going back or it's going up, either down, we just draw the free body diagram first and calculate the equilibrium. And if it doesn't fit of any of the conditions, because in some case like it appears to be plus, it's like what you think is compressive, because if this part is here and it's going like this is called tension, because it's like pulling from the point joint here. But if the joint is here like this and the force is going towards the joint, it is compressive. But in some case the free body diagram of Hugh is like this, but the answer is minus. Therefore, you have to recheck it, and it must be a compressive force. And for this one is the joint A. We follow the same procedure, and this is what we got for each of the force that we're finding. So here is what we found earlier for the joint C, joint A, and joint B. Actually, we have to draw this one before we find the joints. But if you can like look at it from this free body diagram only without breaking into components, it's also fine. But if you feel like it's more comfortable to break into components, so this one is better to like have it before calculation.